everyone, and welcome to this explainer. Today, we're doing something a little different, and honestly, a lot more exciting. We are completely transforming the way you prepare for your exams. Consider this your elite masterclass, a sort of training dojo specifically designed to completely change how you tackle Cambridge IGCSE and O-level computer science questions. We're zeroing in on a topic that, frankly, trips up a lot of students: sound sampling and resolution. But listen, we aren't just going to sit here and recite facts from a textbook today. No way. We're going to build a mental framework that guarantees you know exactly what the examiner is looking for every single time. So let's get started. Okay, let's dive right into this. The absolute biggest mistake students make is passively memorizing definitions. You know the drill, just staring at flashcards until the words blur together. Instead, ask yourself right now, what digital problem does sound sampling actually solve? Before you even think about binary codes or frequencies or bit rates, you need to shift your brain from passive listening to active problem solving. Think about it. Sound sampling exists because the real world is analog, right? It's continuous, it's messy, it's fluid. But computers, they're digital, discrete, and highly structured. They only understand ones and zeros. If you start by answering what core problem this technology solves, bridging that gap between the messy real world and the structured digital world, well, suddenly the terminology becomes meaningful. It's no longer just a string of random words to memorize for a test.
So here is our tactical syllabus for today. First, we'll look at the sound sampling problem. Second, avoiding classic wrong turns. Third, the structured solution path. Fourth, the 3-pass revision cycle. And finally, number 5, the 4 memory prompts.
Moving right along to Section 1, the sound sampling problem. We need to look at this as part of a connected structure.
You see, sound sampling is not just some isolated fact floating in a vacuum. It is a vital part of a connected digital structure. And to master it, we absolutely have to avoid the trap of rote memory. Why do you think so many smart students lose marks despite actually knowing the theory? Well, it's because examiners aren't mind readers, and they certainly don't award points for vague vibes. In IGCSE and O-level computer science, your performance depends entirely on your specificity. You cannot rely solely on short, punchy labels. If you just jot down, "it measures sound waves," you are literally leaving marks on the table. The highest marks require precise terminology. They require clear, sequential explanations of processes. And most importantly, your explanations must connect directly back to the specific scenario given in the exam question.
And this brilliantly illustrates our core philosophy for this explainer. A strong lesson begins with a realistic problem and links the concept to the style of analysis or explanation that appears in examination questions. This is absolutely crucial, guys. This progression is exactly what helps you move from just recognizing a concept on a page to truly actively applying it when you're under the pressure of the clock.
Let's jump to Section 2. This is all about avoiding classic wrong turns by catching errors early.
Think of this next part as a sort of diagnostic clinic for your exam technique. A classic symptom of a weak answer is concept confusion, basically mixing up similar terms. And hey, it happens. You're under exam pressure, the clock is ticking, and suddenly memory and storage look like the exact same thing, or you swap validation for verification. It happens all the time. When it comes to sound sampling and resolution, your theoretical foundations rely on distinguishing these nearby concepts. Your notes need to train you to compare concepts, not just explain them in total isolation. You have to know what a concept is, sure, but you also need to know exactly what it isn't. Let's walk through these common marks-losing mistakes, and I want to do this energetically because I want you to banish these from your exam strategy forever, okay? First, using vague wording. Vague wording is your absolute worst enemy here. Next, confusing similar technical terms, like we just talked about. How about missing a crucial sequential step in how an analog wave is actually converted to digital? Mark lost. What about naming a hardware device without actually explaining how it functions? Mark lost. Or giving an advantage of high resolution, like saying it gives better sound quality, without actually explaining why the file size increases as a result? Mark lost. And the absolute biggest trap of all, failing to answer within the context of the question. Which leads us perfectly into Section 3, the structured solution path. This is your disciplined methodology. So the crucial point is, now that we've diagnosed the illness, here is the cure. This is a highly disciplined 4-step technical methodology that pretty much guarantees a comprehensive answer. Step 1, identify exactly what the task requires.
Is the examiner asking for causes, effects, advantages, or maybe design decisions? Pin that down first. Step 2, classify the relevant data, hardware, or process involved. Step 3, explain how the process works in a clear, logical sequence. Imagine you're explaining it to someone who has never heard of it before. Don't skip steps. And step 4, the critical final piece of the puzzle. Connect your explanation firmly back to the context.
I like to call this the scenario anchor motif. Anchor your answer. If the exam question sets up a scenario happening in a school or a robotics lab or a security incident, your answer absolutely must stay locked inside that context. Look, we've all had that moment of panic in a test where we just dump every single fact we've ever learned onto the page, just praying something sticks. But generic responses rarely gain full marks. You have to diagnose the demand correctly and then tailor your technical knowledge directly to the scenario on the page.
Now, the absolute best way to practice this anchoring technique is through real-world transfer contexts. Things like smartphones and websites, school systems, industrial control, secure communication, or robotics and embedded systems. Sound sampling happens in literally all of these domains. But here's the kicker. The reason for using it and the consequences of choosing a high or low sampling resolution change entirely depending on the scenario. For instance, a basic security robot might only need low-resolution audio just to detect if a loud noise happened. But a premium music streaming website, that needs ultra-high resolution. Showing these links helps you remember the real reason for using a concept and the trade-offs of choosing one method over another. All right, on to Section 4, the 3-pass revision cycle. Let's look at layered study. Let's move to this and see how this builds, because you might be wondering, how do you actually study this dense material so it truly sticks in your brain? The answer is a chronological layered study progression. Pass 1 is all about securing your core definitions and contrasts, just getting the foundation solid. Pass 2 is where you start rehearsing your explanations and physically drawing out those diagrams of sound waves being sampled. Get it out of your head and onto paper. And then pass 3, well, this is where the magic really happens. This pass is entirely focused on exam adaptability. This 3-pass cycle is absolutely vital because, as you know, exams rarely just ask for a simple definition. They combine theory with applied reasoning. Which brings us to the core definition of that 3rd pass, exam adaptability. It's the ability to change the scenario, mix similar terms, and actively justify your technical choices under testing conditions. This is the whole shebang. It is your ultimate defense against those unexpected, curveball exam questions that make your stomach drop. If you are adaptable, it honestly doesn't matter how they phrase the question because you already have the tools to deconstruct it. Finally, Section 5, the 4 memory prompts, your ultimate readiness checklist. Now, what's really interesting about this slide is that this matrix is your ultimate exam safeguard. It is a highly actionable, final mental checklist to test if a topic is truly ready for exam day. For any concept you study, especially complex ones like sound sampling and resolution, ask yourself these 4 prompts. Number 1, what is it? Number 2, how does it work? Number 3, where is it used? And number 4, why choose it over an alternative? If you can confidently articulate the core definition, the sequential process, the real-world scenario anchor, and the better or worse evaluation, you are fully armed for maximum marks. But hey, here is the hard truth. If you look at those 4 memory prompts and you cannot answer them out loud, fluently, clearly, without stumbling, then you are simply not ready. And that's okay. But it means you need to go back to the dojo. You need to actively rebuild your understanding. Start from a key contrast, then look at a worked example, and finally, apply it to a brand new scenario-based question. Don't just passively reread your notes. Rebuild the concept from the ground up. So, I want to leave you with a direct, energetic challenge. Put everything we've talked about today to the test. Can you apply those 4 memory prompts to justify sound sampling in a robotics scenario right now? Think about the specific problem it solves for the robot, the sequential process it takes to convert that sound, the unique context of the robotics lab, and exactly why you choose a specific audio resolution for that machine. Master the structured approach, and I promise you, you will flow through your exams with absolute, undeniable confidence. Thanks so much for joining me on this explainer, and keep practicing.